Hello, folks. Greetings. We're going to continue our discussion on antiderivative, and we're going to learn what we call as a chain rule. Right now, when you study derivatives, you would have learned the chain rules. So this, uh, when you're studying antiderivative, again we have a chain rule, right? So again, all of these rules, all of these things that we learned so far, it's basically, by now you would have understood that in mathematics there are different conceptual operations, right? One of it is about derivatives, another of it is antiderivatives. Now later in time we're going to also talk about integrals, right? And what you're actually learning is that, when we all started with arithmetic, the teachers taught us how to do some basic arithmetic operation, and there were rules with it. Then we jumped to algebra. Again, the list of rules increased. And now we are in studying calculus, and of course, we just need to remember these rules. And the best way to remember these rules is what I would call as, drawing up a mind map, which we'll do after we learn these chain rules, because, we learned quite some number of rules for antiderivatives. And if we keep all these rules in mind, then it's the question of using those rules to solve problems. And then when we talk about solving problems, the best way to do this in math is that once you have this mind map, I would start solving problems, keeping that mind map printed out and in hand. Okay? And over time, if you can solve the problems with that mind map in mind, then over time, what you could do is, now you take off the mind map and then do it. So then you'll remember all these rules, because that's what is the difficulty I'm seeing right here with kids, is that, well, yeah, I can understand these rules. When the teacher taught me these, I think I understand the rules. But then afterwards, when the problem is set before me, I forget all these rules. And that's normal, okay? But if you put some effort in coming up with this mind map and using the mind map to solve problems, then you will remember them. And then the other advice I'll have for the kids is that, so you take these notes, so you have the mind map, the problems that you solved, preserve that somewhere, so that when you have your midterm test or a final test, then you can go through those, remember those ideas that you learn, and then you'll do very good in your test. Okay, so we are going to go through all those concepts. And as I'm following this book where we get problems, for this particular section, there's, I think, 20 odd problems. And what I'm going to do is, I'm going to put more and more videos, because I realize that if I can solve some of those problems, then you can follow the same pattern and solve more problems, right? And hopefully that will help you get a very clear understanding of what calculus is all about. Okay, now let's start with, the thing called a chain rule, right? Now let's start with, so one of the antiderivative, this is antiderivative chain rule. It comes from the derivative chain rule, so let's start with that. So the chain rule says like this, okay? If, let me choose a color. If dx by dy is equal to ax plus b the power of n, then y equals, now as usual, they have given you the derivative, you got to find the root function, which is the antiderivative, right? So they're just saying that, hey, that is equal to ax plus b to the power of n plus 1 divided by a multiplied by n plus 1, okay, plus c. Of course, c is the constant, and another important information here is a cannot be 0, because if a is 0, then you get into a situation where you're dividing something by 0. That will not work. And n cannot be minus 1. Again, the same thing, if n is minus 1, then things will become 0. So for a not equal to 0, for n not equals minus 1, if the derivative is ax is of the form ax plus b the power of n, then the antiderivative has to be ax plus b to the power of n plus 1 plus c, and divided by a n plus 1. Okay. So it's easy to remember this formula, but how did this come about? Let's figure that out. So we are going to prove this. Let me see. Well, I'm just going to clear the screen. So we're going to prove this stuff, okay? So as I told you, that the best way to prove this kind of thing is that let's go and find the derivative of the result, right? And if we find the derivative of the result, if it comes with whatever we originally envisioned, then it is true, right? So what we are going to do is we're going to find the derivative of ax plus b to the power of n plus 1 divided by a multiplied by n plus 1 plus c. Okay, so we're going to find the derivative of this whole thing, and if we find the derivative of this whole thing, then we can find out if the idea of if dy by dx is ax plus b the whole power of n, is it this, right? So that's the idea. So the result I need to get is ax plus b to the power of n. Okay, so if I'm finding the derivative, you can see that the initial part, that is 1 by a n plus 1, this is all a constant, right? And you know, when you're trying to find derivatives, a constant multiplied by a variable function, you take the constant out, separate it out. Okay, now when you separate it out, what you're trying to find is the derivative of ax plus b to the power of n plus 1. Okay, and this is where you will know that the derivative of ax plus b to the power of n, what is that? If you remember, right, that is actually equal to a, right? Then you just say n, right? So you have an, then you'll have ax plus b to the power of n minus 1. Okay, so you'll have an multiplied by ax plus b to the power of n minus 1. This would have been the derivative formula. Okay, so basically if you want to do the derivative of, then that is the formula. Okay, now things are a little different. Instead of n, you have n plus 1. You got it, right? So if since so then what happens is I'm just going to say a, okay, that is multiplied by, instead of n I have n plus 1, so I'm going to put n plus 1. Okay, and then I'm going to put ax plus b to the power of n minus 1, but instead of n I have n plus 1, so it's n plus 1 minus 1, correct? So as you can see, then if we do that, then a n plus 1 and a n plus 1 cancels out. N plus 1 minus 1 becomes n, and therefore that is equal to ax plus b to the power of n. Of course, then you will know that if there is a c, you try to differentiate c, that is a constant, so the constant will not be there. So what has happened is that if dx by dy is equals ax plus b to the power of n, then the root function, the antiderivative, is ax plus b to the power of n plus 1 divided by a multiplied by n plus 1 plus c. Okay, it's as simple as that. So this is the simple chain rule, and of course you will get problems where the problems of the form, hey, find the antiderivative of something x plus some other constant to the power of n, then you will apply this formula. Okay, that's great. I did that in 13 minutes. So now the next thing I'm going to do is that I'm just going to, so there is a, I'm going to do one more chain rule, and this chain rule is called as the general chain rule. Okay, so that one was a simple chain rule. Now we are going after a general chain rule. What is a general chain rule? And this is also simple. If dx by dy, or sorry, dy by dx, let me erase that. Dy by dx, okay, equals a function prime of x. Okay, so basically it is a derivative of x, right? One derivative of x multiplied by the function of x to the power of n. Then what is y? So the derivative of y by dx is of the form a derivative of x and then the function of x to the power of n. So in that case, y is supposed to be 1 by n plus 1, okay, and multiplied by the power of the function of x, any function of x by the way, n minus to the power of n minus 1 plus c, and here again c is a constant and n cannot be minus 1. Okay, so basically it's a generalized chain rule where you get you're looking at the derivative of a function, right? And when you look at the derivative of the function, it is of the form f prime of x, which is the derivative of that function, multiplied by that function to the power of n. If that is the situation, then all you need to do is you forget about the f prime of x, right? But you just say that hey, it's n plus 1 multiplied by the function to the power of n minus 1 plus c, and that will be your generic chain rule. And so now it's the question of proving that, right? Again, why is this formula provided to us? So that we can apply this formula in certain cases where we get functions of the form, something multiplied by something to the power of n, okay? So when we solve the problems, we'll get to it, but right now we need to prove this, okay? So let's see how we can prove this. Let's clear this screen up. And we can just say that, okay, so if I need to prove it, again, the best way to prove that something is a antiderivative is that find the derivative of the antiderivative, right? And check if it checks out to that particular derivative, right? So let's start with what is the derivative of the answer, okay, which is f of x, the whole thing, power of n plus 1 divided by n plus 1 plus c, right? This whole thing, you got to find the derivative of that whole thing, okay? So what's the answer? Now that will be equal to, again, 1 by n plus 1 is a constant, so we separate that out, right? And then we say that, oh, how do I find the derivative of f of x to the power of n plus 1, okay? So again, here is the formula for that, for a derivative, okay? For the derivative, if you say that, hey, what is the derivative of f of x, a function of x, okay, to the power of n. Okay, if you are given a derivative of f of x to the power of n, what will you do, right? How do I find the derivative of f of x to the power of n, right? And this again, we study derivative. There is a derivative chain rule like this, okay? It will be f prime of x, that is, you find the derivative of x, okay, of that function. The function that's inside, you find the derivative of that, okay? And then you will say multiply that by n, okay? Then take that function and put it n minus 1. Well, let me rub this and do this a little bit better because I ran out of space. So that is equal to use that, equal to f prime of x multiplied by n multiplied by f of x to the power of n minus 1. Okay, that's the derivative formula. So if I apply that, instead of n, I have n plus 1. You see that? So that will be n plus 1 multiplied by f prime of x. Okay, that multiplied by f of x to the power of, so instead of n you have n plus 1, so when I say n minus 1, it is n plus 1 minus 1. Okay, so as you see, again this n plus 1 and n plus 1 will cancel off, and then that will become equal to f prime of x multiplied by f of x to the power of n, because n plus 1 minus 1 is n. Again, if the plus c, when you find the derivative, that's going to be 0. So that is your answer. Okay, so these are the chain rules that you will have to remember in order to find antiderivatives. Now, there's going to be further things that's going to happen, but this is another generic chain rule that you can apply on your problems. Okay. Now again, this is a 20-minute video is what I promised. So this is 20 minutes. So this explains you explains you what the chain rule is. Okay. Now, in the next class, what I'm going to do is I'm going to take all these rules and put together a mind map. What is a mind map? It's just a little picture of all these formulas and all the things that we learned so far. Probably, hopefully I can share the link with you, but you know, it's better when you are drawing a mind map, it's better for you to take a piece of white paper, and a mind map should not be more than a white paper or one piece of white paper, right? In landscape mode. That's usually the way I do it. So we'll do that, we'll keep that aside, and then we'll get into some of the problems that we can apply these formulas to some of the problems. And the problems, the wording of those problems is the one that will trip you down. So we'll go through each of the wording to really understand what it means. But for now, keep this chain rule in mind, and let me know if you have any questions. Okay, thank you.